Okay, so let's go through exam number 1 here for the summer semester and see if we can come up with the answers. All right, so we'll look at number 1 of page 1. So it's just asking for the chemical formula. The easiest way to approach this, or I should say one way to approach this, right? Let's identify our carbons. Remember at the beginning and the end of every line, right, that's where a carbon is. So if I do my counting, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, let's do this again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it looks like we got C10. The next thing I would do is come in and fill in any hydrogens, right, that might be missing, right? Remember, we fill in the hydrogens to make sure that everything has, that each carbon has 4 bonds to it. So let's count that. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Let's count this again. There's 5, 6, 7, 8, 9, 10, 11, 12, 13. So that looks okay to me. And then the last thing we got to do is we got a nitrogen there, so C10H13N. Got it. All right. So let's look at the next one here. We're going to do the same thing at the beginning and at the end. All right. There's a carbon. All right. Count 1, 2, 3, 4, 5, 6, 7. So it looks like we got C7. Let me count this again. 1, 2, 3, 4, 5, 6, 7. Okay, that looks good. Fill in any missing hydrogens. We got that. And then we got this guy here at the end. Don't forget that guy, right? So how many hydrogens we got? 1, 2, 3, 4, 5. All right, so H5. All right. We got 1 nitrogen. Whoops, didn't mean to do that size pen there. We got that nitrogen, and then we got 2 oxygens. Cool. Okay, there it is. Alkynes tend to be somewhat tricky, so just be careful of alkenes and alkynes. Double bonds and triple bonds kind of make things a little bit trickier. Okie dokie. So predict the formal charge for the following. I could keep tabbing over, but you're going to need a periodic table to do this, right? There's multiple ways of doing formal charge. There's the magic science circle, right, which we talked about in class. There's formulas you can use. So it doesn't matter which way you want to do this, just you need to know how to do formal charge. So if you are having trouble, I don't want this video to be 5 hours long either. So if you're having trouble finding the formal charge, I'll do it here. I'll do the phosphorus one here real quick to see how I got +1 there. So I'll just show you how I do one of them, and then hopefully you guys can go through and do the rest. Okay, so what I do is, all right, I imagine a circle cutting through all the bonds around the atom. Then I count. All right, I have four atoms in my circle, and phosphorus starts out with 5 valence electrons. So valence minus circle, right, gives me my answer of +1. Right. So that's how I do my formal charges. So I do my magic sign circle. You do that for each one. Valence minus what's in the circle, you get your answer there. Okay. So, but you need a periodic table to figure out your valence. I mean, unless you got it memorized, but I'm never going to make you guys memorize it. So same thing over here. All right. So, all right, not much else to say about formal charge. You got to know it, right? Remember, the big secret of organic chemistry is finding the negative, finding the positive, bringing them together. Okay. Draw the complete Lewis structure for all isomers of C2H6O. Okay. We can start with maybe the first one to think of, right, where we just tether all of our carbons and our oxygens together, and then we just can come back, fill in our hydrogens. There's our 6 hydrogens. And then we fill in our remaining lone pairs, okay? So remember the name of the game, everything in here, right, everything in C2H6O follows the octet rule, right? Everything follows the octet rule. So carbon better have 4 bonds, oxygen better have, excuse me for just a second here, oxygen better have follow the octet rule, right? Not have more than 2 bonds to be at a nice, happy state. Hydrogen better only have 1 bond because its quote octet means it only has 1 bond to it. All right, and then the other option is, right, this. Right, so we have a set of constitutional isomers here, right? They have the same formula but put together differently, right? The other thing I was kind of pointing at is, right, we've got, right, this is an alcohol, right, and this is an ether, right? So different functional groups also is kind of the way that you might be able to approach this also, right? What different combinations of carbon, hydrogen, and oxygen are there in terms of functional groups, right? There you go. Okay. Cool. Next. Draw the best molecular Lewis structure for the following molecules. Make sure to show all bonds, indicate the hybridization, okay, and provide the name of the molecular geometry. Sounds good. All right. So I'm going to walk you guys through it. Okay. Cl2SO. The least electronegative atom goes in the middle. We connect everything. We connect our other atoms to that central atom using single bonds, right? We have 2 chlorines that have 7 valence electrons each. That's 14, right? Sulfur has 6, and oxygen has 6, right? So we have a total of 26 electrons we got to deal with. We've already used 6 of them, so we got 20 more to go, right? We got 20. Let me see if I can clear this up here just a little bit. Cool. All right, so we got 20 more electrons to go. We've already used 6 of them, so let's fill it in. You fill in electrons from the most electronegative or from the outside in. Okay, so I'm filling in everything to make an octet. All right, what do we got? We got 6 electrons in our purple bonds. So 6, we got 8, 10, 12, 14, 16, 18, 20, 22, 24. All right, so we've already used 24. Everything's got an octet. Blammo, 26 on the middle there, okay? All right, so there is our Lewis structure that we have, but we're not quite done yet. We have to show all bonds and show 3D shape, okay? So this is, the way we have it drawn right now, it's a flat planar molecule. But if you notice, let me switch colors here, right? We have 1, 2, 3, 4 things around that central sulfur, okay? If you have 4 things around a central sulfur, it's not a flat molecule, right? It's going to be the electron domain geometry is going to be tetrahedral. So we got to redraw this here, right? So we got to make this look like a tetrahedron. So here we go, okay? Every time you got to draw a tetrahedron, it's going to look like essentially like this, right? Then let's just fill in things right here. We'll put our lone pair there, right? We'll put a chlorine. Sorry, let me switch. I didn't mean to. There we go. Chlorine, chlorine, oxygen. Okay. You fill in the other things. Nice. Now, as we talked about in class, right, there's not really a bond to a lone pair. So if you just left it like this, right, if you just left it like that, that's fine too. I'm not that picky. I know, like, I know what you guys are talking about when you get this, and right, it's just easier to draw tetrahedrons when you start with the same shape over and over. That's the only point that I want to make, okay? All right, the other question that I wanted says, provide the molecular geometry, right? This is trigonal pyramidal. Cool. Okay, so that's, oh, I forgot I indicate the hybridization. Sorry, that's sp3. Okay. There we go. Now I think I got everything. Now, let me talk about this Lewis structure right here, okay? Now, if you go through and do formal charge, you see that the sulfur has a +1 and the oxygen has a -1. And so, you could end up doing this. And by doing that, you minimize the formal charge. Now everything's got a 0 formal charge. It means that sulfur is violating the octet rule. That's fine, okay? That's fine. Sulfur can violate the octet rule. I wasn't that picky on this exam. Technically, this is a better Lewis structure, right? Technically, that's a better Lewis structure there with the double bond. Or I should say better, as in more representative of what's actually going on. But I'm not too picky on that yet, okay? So either one of those is just fine, okay? It's not going to change our answer, right? It's not really going to change our answer. Okay, so let me clean this up. That's not what I wanted to do. All right. Delete. Delete. And then. Cool. All right, so let's do the same thing for the next molecule here, CNO. We put the least electronegative in the middle, carbon, right? Connect everything together. Here's my oxygen, there's my nitrogen. Carbon has 4 valence electrons, nitrogen has 5, oxygen has 6, and you add 1 for the -1 charge, right? So we have a total of 16 electrons to deal with, right? We've already dealt with 4 of them. So 4, 6, 8, 10, 12, 14, 16, okay? There's my 16 total electrons. Now, obviously, you see a problem. The carbon in the middle there is deficient of electrons. So, didn't mean to use that sizer, right? So, we turn lone pairs into double bonds. And we have a choice, right? Here we're left with a choice. If we make this structure, right? If we make this structure here, then we're left with this. Okay. And you say, well, that looks nice. I like that, right? Now remember, if we've got a minus charge here, we better account for it in our Lewis structure, right? I mean, really, you should always check formal charges, right? I mean, well, not really. You always need to check formal charges. You always need to. I don't know why I said really there. I didn't mean to say it that way, right? But this should be unusual because now we've got a -1 on a nitrogen, but we've got an oxygen over here, right? Remember, one of the rules with formal charges is if we can put it on the most electronegative atom, put it on the most electronegative atom, right? So really what we should have done is this. Right, so we make here, there's nitrogen, we make a triple bond, all right. All right, now we got a -1 over here. There we go. Okay. So here's the two choices that we have, right? The -1 on the nitrogen, the -1 on the oxygen. The -1 on the oxygen is probably going to win. This isn't a bad Lewis structure, okay? I don't want to give that impression. I'm not saying this is a bad Lewis structure, but I was asking for a best Lewis structure, okay? You know, based off the rules that we know for now, this is the best Lewis structure over here that we have, okay? All right, so same thing. Let me clean this up. Okie dokie. Moving right along. O2F minus. All right. So least electronegative in the middle. Connect everything together. Boom, 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 boom. Oh, geez. Sorry. I hate to do this. Let me hop back. I forgot this stuff here. This is SP hybridized, and it's linear. Oh, man, I would have gotten partial credit on the exam. All right. So I am just filling in the blanks quickly here for this guy. There we go. Okay. I'm going to zoom out so you guys can see all of page 1 of exam 1. And there we go. I'll see you guys in the next video.